Session 06, a Capstone project combining FastAPI, Celery, and WebSockets. We will build a distributed system that processes heavy background tasks and streams real-time progress updates through a WebSocket connection. The architecture covers three main areas: system overview, backend processing, and full-stack deployment. The system architecture from end to end. A client sends a POST request to FastAPI. FastAPI enqueues a Celery task and returns the task ID immediately without blocking the request. The worker processes the pipeline and publishes progress through Redis pub/sub. The WebSocket endpoint listens to the Redis channel and forwards each update to the client browser. Define the Celery application with Redis as both broker and backend on separate databases. Production configuration: task_x_late ensures tasks are not lost if a worker crashes, and worker_prefetch_multiplier set to 1 distributes tasks fairly across workers. A separate Redis pub/sub connection on database 2 keeps it isolated from the broker. The heavy task simulates a processing pipeline that loops over each data item. Each step calculates the completion percentage and publishes a status message through Redis pub/sub on a dedicated channel named after the task ID. The client receives the entire progress stream over WebSocket without any HTTP polling. When the pipeline finishes, a success message tells the WebSocket to disconnect. The WebSocket endpoint is the heart of real-time communication. FastAPI accepts the WebSocket connection and subscribes to the Redis channel matching the task ID. An asynchronous loop pulls messages from pub/sub without blocking the event loop thanks to asyncio.sleep. Each received message is forwarded to the client via send_JSON. When the status is success, the connection closes and resources are released in the finally block. The detailed progress flow. The worker computes each percentage and publishes it to the Redis channel. The WebSocket endpoint polls asynchronously, receives the message, and forwards it to the browser client. Client-side JavaScript updates the progress bar in real time without reloading the page. The entire pipeline is non-blocking. FastAPI returns the task ID instantly, and the WebSocket pushes continuous progress until completion. Docker Compose packages the entire stack with 4 services: Redis as the message broker, the FastAPI web server, a Celery worker for task processing, and Flower for monitoring. A single Docker Compose up command starts everything. Use curl to call the trigger API and create a task, then open a WebSocket connection to watch progress in real time. Session 06 Recap. We built a complete FastAPI, Celery, and WebSocket system from end to end. The Celery worker processes heavy tasks and publishes progress through Redis pub/sub. The FastAPI WebSocket listens to the Redis channel and forwards real-time updates to the browser. Docker Compose packages the entire stack into a single command. Session 07 will dive into testing strategies for Celery tasks and distributed systems.